We're now going to move on to another project that is analyzing images, but this time for the purpose of making them more easily accessible to visually impaired people. So annotations of images, and to present we have Dr. Christoph Lofi from University of Delft, Technical University of Delft in the Netherlands. Please.
Welcome everybody. My name is Christoph Lofi and I'm from TU Delft University of Technology. And I'm here today to talk about describing images for the visually impaired. And this is part of our Future Library Lab. The Future Library Lab is a very interesting collaboration between TU Delft as an academic research institution and the Royal Library in Den Haag as well, a public top-level library. And within that Future Library Lab, we try to research and look into different topics about how to innovate libraries as they are today and make them fit for the future. And this covers many different research lines, like, for example, what kind of services a library should offer, or how different people, customers might be interacting with a library, but also technical challenges, like, for example, how to use artificial intelligence and electronic technologies in order to support, augment, and make libraries as they are better and fit for the future. The Future Library Labs covers a lot of people, but the talk today will be focusing on a smaller team of 3 students and myself. We have been working on this for quite a while. And what I'm going to present you is how to annotate images, and especially for the visually impaired. However, the mission of image annotations doesn't just stop there. So in the end, this topic is about making our document collections and library collections more accessible. And as you might know, in 2025, we have the European Accessibility Act coming up, which demands that all, digital collections of material which is offered by, public entities needs to be as accessible as possible. And that is, of course, a big challenge which we are facing, and where our current methodologies and our current tools are not really fit to help us. Good. So let's have a look on what we are trying to do in this project. So essentially, we are focusing on 2 research questions. The research question 1 is, how would visually impaired readers effectively consume information conveyed by images? So this is more research question focusing on the process, on the design of these systems. And it's a still ongoing challenge, so we do not have conclusive result yet, but we have been looking into these things for quite a while. Research question 2, and that's a research question I'm personally interested in because, I'm a computer scientist, and as a computer scientist, of course, I'm very fond of technology, and that's the typical thing I'm good at. So research question 2 is a more technology oriented one, and that would be, how can the content of images be described to suit the needs identified in first research question of visually impaired readers in an efficient and cost-efficient manner? So essentially the question is, faced with the massive collections of content which we have in most systems right now, how can we annotate these images effectively? Good. What do I actually mean when I say image annotation? And why can't I just be using, one of these wonderful AI deep learning systems everybody has been talking about? Well, I took an image like this one here, which I found on my desktop computer somewhere, and asked one of the leading deep learning systems which are available from a commercial perspective to annotate that image. And actually, the image annotation I got wasn't even that bad. So what was produced was like flock of birds and space shuttle with blue sky. This is definitely not wrong, as we can see. I mean, here's a space shuttle, there's a flock of birds, there's a blue sky, here's a bunch of clouds. No, the image annotation doesn't talk about, but it's also not relevant. But now the question is this actually a good image annotation? Well, depends, right? I mean, yes, the elements are all there, but of course, the interesting aspect of that was this image was not by itself it was found in a larger text about, well, the Challenger disaster, where, well, the Challenger space shuttle exploded briefly after launch. And there was text around it. There was also descriptions around it. But of course, these deep learning systems, and they are quite good, but in the end, they just focused on the image itself and completely missed the image content. And maybe a better image description would have been Challenger space shuttle briefly before it exploded. And maybe I don't really need to know that there's birds and blue sky. But this is a little bit what we try to achieve here. Good. How did we approach this project? Well, in a pre-study, we first try to understand how the current annotation process for images, especially with visually impaired users, would work right now. So we went to different libraries and different publishers and asked them, hey, how do you do that today? And it turns out that nearly everybody we talked to was claiming that today they do that in a fully manual fashion. I mean, yes, there are technologies around which could help, but it was tricky for many of our interview partners to either use these technologies, or they didn't consider them good enough, or they couldn't get them to work in an efficient fashion, or it didn't fit their workflow. So in the end, it turned out most of them did these annotations in a manual fashion, and mostly using very expensive and highly paid experts. Now, the reason why experts are used for that are quite obvious, because in order to make a good image description, and especially with visually impaired users in mind, well, one needs to analyze an image quite deeply and put it into context and provide an image description which is meaningful. So one needs to anticipate the need a potential user of that image annotation might have. As a result, it was often reported that the cognitive load on annotating images is very, very high. So this is a very taxing process for the experts. And because of that, the scale of this process is very limited. So annotating images fully manually relying on experts is quite expensive. Good. Therefore, we developed different ideas. And one of the more obvious ideas was like, okay, let's try to scale this process out. So maybe we do not need to rely on only experts. Maybe it's good enough to combine also non-experts, maybe with some expert judgment, and maybe also with existing technology. So what we would have in mind is a hybrid system, combining these different components and make it as efficient, effective as possible. And this is something we quite commonly do in these scenarios. Because unfortunately, even though we are living in the age of the big renaissance of AI technology, and we kind of shamelessly rebrand all our research as saying like, hey, now we do AI. If you're really honest here, a lot of applications do kind of work. There was a lot of impressive progress, but rarely we can just use these systems out of the box and then fully trust and rely on the results. So in the end, we always require some kind of human oversight and some kind of human steering in order to get the results we want. And maybe we will get to the point in a couple of years where these systems are reliable enough by themselves, but right now we are clearly not there yet. So from our perspective, it's a given that humans need to be in the loop in this process. Now, of course, the question is, which humans? Do we require these expensive experts, or can we also use, well, more people, which are maybe even cheaper to use? And this is a process we typically call crowdsourcing. And there have been a lot of very effective examples of crowdsourcing being used. So there's a lot of different platforms where we can recruit different workers, either for money or even volunteers, to contribute their insights and their work time in order to get this done. Now, this was one of the first projects we followed. So in a pre-study, we looked at a potential human-based but scalable system, which was trying to scale out the process by relying on crowd working. And this is a little bit what we ended up with. So maybe if I zoom in here, what we can see is that the core idea there would be that the publishers provide material, then it goes into the system. And what was identified in this pre-study, and this was done by our design faculty, so this is not a work done by myself, being a computer scientist, but this was more from a design perspective. But what was identified from a design perspective is that depending on the use case, visually impaired users might have different requirements when it comes to the image annotation. So in this process, it was envisioned that there's an interactive interface for the consumers and users, where first they get provided with a very basic description of the image, but when that image description is not sufficient, then it can be refined and a better image annotation can be requested. So by doing that, we can identify the images which are required from a user perspective. However, the problem is if a consumer identifies an image which is super important to them, we wouldn't necessarily have that image annotation. So basically what happens in the background is, as soon as an annotation is requested, this annotation request is outsourced to a larger crowd of workers, which are recruited from a larger recruitment pool, for example, on platforms like Amazon Mechanical Turk. And typically for a little bit of money, they would provide these annotations. Now, this process, of course, is not real time. So it can still take a while until an image annotation is provided. So worst case, our user from the previous slide has to wait for a while, or it might only benefit the next user. But with a system like that, we can at least tackle the question of how do we scale all these expensive experts. And yes, we believe by using a more crowd-based approach, this can be done. Now, there's a lot of, let's say, problems to that, which need to be solved. So, for example, how does one instruct these crowd workers to provide good, high-quality image description, how to control the quality, how to make sure that everything is as we want it to be, but it can technically be done. Good. There's also some more detail to this image process, but I guess I do not want to go into detail here. So if you're interested, we can provide you with a full project report where all of these different steps are, well, discussed in more detail. But I would also want to talk about a slightly different approach. So instead of tackling the issue of scale purely by involving more people, which is, of course, a solution, of course, right? Instead of just using few expensive experts, we can just use a lot of people and have some work on this collaboratively. But I would also like to look at the potential of modern AI technology to help us out. Now, the problem with a lot of AI technology, and especially AI technology for computer vision, is that developing these tools is very, very, very expensive. So there are currently a couple of companies and also academic institutions who develop their own deep learning image recognition and image classification modules. And typically training one of these systems will easily cost hundreds of thousands of dollars and consume a lot of computational power and also consumes a lot of data. So this is not something, me or probably also not you can easily do, and especially not in a couple of hours and days. So in the end, we were faced with the challenge, okay, can we maybe use off-the-shelf software with somebody else, in this case, for example, Microsoft or Google, or there's a bunch of other providers who on a pay-per-use basis provides this service. Can we use these services in order to get these image annotations? And we checked that in a pre-study, and our initial result was yes, to some extent. So many of the inputs we got or outputs we got from these systems were not wrong. It was a little bit like the space shuttle example I had before, flocks of birds with spaceship. Yes, of course, it's correct. But they were typically lacking the focus and they're typically missing a little bit the point. So I would say, yeah, these technologies are useful, but not by themselves. But maybe they can be useful when combined with other things. And this is essentially the approach we came up with. So how about we start with automatically generating text or text using these out-of-the-box frameworks, and then also having a look at the surrounding publication in which we found that image. Because as I was also saying before, these images are not necessarily in isolation. They are part of a bigger publication. And then also deploy automatic text analysis software and technology in order to try to understand the text, which is as limited and as error-prone as image processing. But by combining these two, we might be able to improve the image description and then return that image description to a human worker. And our claim would be that refining an automatically generated image description, which is in addition augmented by some text and context analysis, this is much, much easier to do and requires much less cognitive load than coming up with image annotations from the scratch. So soon we will be running a study on actually measuring and quantifying that approach, but essentially this is what we try to do here. Good. Let's have a look at a few examples here. So one of the examples we found in the newspaper, which we're looking at, and here we got this weird image of this tractor in the night. And what we got from Azure, or Microsoft Azure here, was a close-up image of a truck. Now, this is obviously wrong. It's not a truck. However, nearly all of these systems also work with a certain probability and a certain certainty. So even Azure itself knows that it's not really certain, because it claims, well, it's most likely a truck, but it could also be a tractor. It just decides on truck because, you know, it believes deeper into the truck theory than it believes in the tractor theory. However, when reading the text surrounding it, it says like, okay, this is an illustrative image of an incident where a 23-year-old man stole a tractor at night and then, you know, rampaged through the city and destroyed a lot of cars. So by reading that text, we now can infer a little bit that most likely this is a tractor and not a truck. So we can use our insights into the surrounding text to understand and fix this image annotation and improve it. Yeah, our second example, which we had from a travel guide, this is correctly identified as a canal with a bridge and some trees. Fine. However, it's not just any bridge and not any canal. I mean, this is a rather famous skinny bridge in Amsterdam, and it's a very special bridge, and it's famous for being, you know, painted white, and there's a lot of history and connection. So one should mention that this is the skinny bridge in Amsterdam. But how would the system know that? Well, either we would need to train it on Amsterdam data, or again, do some context analytics and figure out what's going on there. Good. So in the end, we end up with a prototype system which analyzes surrounding text and then tries to combine that with the image annotation, which is provided by out-of-the-box systems, in the hope that this will improve the image annotation, then give that back to human workers, either experts or the general crowd, and ask these people to improve until we get the quality standards which we need. And hopefully we can then show in later experiments that this works well. Good. All awesome. Very great. However, I was just wondering before doing this presentation, if this will really work in practice well. So I was looking around in my office, and in my office I found like a couple of random magazines and books lying around. I just opened them and flipped through it and tried to find what kind of images and what kind of text I would find in these. So essentially I started here with this wonderful Home of Innovation magazine, which is our marketing magazine, which we publish here at TU Delft in regular intervals. And when looking into that magazine, what we see here is a lot of images like that. No? This is our director of AI technology. And I'm not really sure what Azure would do with it. Probably say like, yeah, middle-aged man in front of some background. No idea, I mean, didn't test it. But what's more interesting about it, I mean, he's just not randomly somebody, he's a rather famous person within our university. So here I would have expected an image annotation which reflects that in some way. How would we get there? Well, either by analyzing context again, or maybe by even using some face recognition technology here and training that with the relevant people which we have in our collection here. And, you know, already mentioning face recognition technology opens up all kinds of interesting challenges when it comes to morals and ethics, and if this is really something we want to do, but that would be the more obvious technical solution. Also, when flipping forward in this document, I end up on a page like this one here, where we again have a similar type of image, but more interestingly here, an infographics. So this would be an image which would be super relevant for a visually impaired reader to get. Yeah. Then also we have our wonderful teaching guide from our university, and it has a lot of interesting images like this one here. Yeah, stack of paper. Is this really an image I need to annotate and waste either time, effort, or money on? Probably not. So this image is purely decorative, so maybe we can safely skip that. Also, we find an image like this one here. That's the image on, well, fraud at university and during exams. And indeed, now we have an image on, yeah, students doing an exam. And I guess we can find an image description, but this one is also a little bit borderline. Do we really need an image description? Because it does not really support the text that well. So essentially what I'm saying here, I have a couple of more examples, but I guess you get the point. So essentially what I'm saying here is, even when using a technology like ours, I think there's still some components missing here. So for example, we need to identify what the purpose of an image is and use that to steer and guide our classification, annotation, and understanding process. So for example, I believe we can skip all images which are purely decorative, but then should pay special care on images which are super informative, like infographics and diagrams. But then, unfortunately, we need special technologies working with these tools, because one of the shortcomings of many general image classifiers like Azure or Google Visual is that they are good with general photos, but they typically don't work well with diagrams, infographics, comics, or whatever other thing which might be in our collection. And these need to specialize. Then we need to specialize all of our technologies to the specific document collection. So for example, if I'm having a travel guide on Amsterdam, it's not enough to identify a bridge as a bridge. I mean, I need to identify a specific bridge. Or within our university context, it's not enough to say it's a man. I mean, it's a specific man, so I need to be able to identify these people. So I need additional specially trained recognition software for that. Then I saw in many of these annotations that they use very, very cool layouting, you know, stuff like these very fancy things like that. I mean, it's essentially 20 images in one. And this can pose a big, big challenge for a lot of extraction technology. And in the end, I think the final conclusion is whatever we do here, I think the inclusion of humans in this process is still mandatory, and we need to find a way to make that as effective and efficient as possible. And I think with that, I would thank you for your attention and happy to answer any additional questions.
Thank you, Christoph. A question, have you already produced the final product or the interface? Do you have an idea how it will look like? Is it going to be voice controlled, or how will you approach these visually impaired people?
Yeah, right now our technology is intended to work purely as a back-end technology. Mm-hmm. So we are going to provide the image annotations, which are then added to the documents and to the web pages or whatever it is. So the question of how people interact with it, it's not a question we are addressing right now. Mm-hmm. So we are purely looking at it from a data annotation point of view.
Okay, well, have you sort of tested it or validated it already on a sample of these VIPs on your diagram, even though you don't have a user interface yet?
So right now we are evaluating it with annotation experts. Mm-hmm. So essentially the people who typically as a job would be doing these annotations. And preliminary results show that indeed the mental effort for creating these annotations is now lower than it used to be, because now people are just improving annotations instead of coming up with new annotations from scratch. So that's already a success. However, the question then how the visually impaired people would interact with these annotations, I think that's something we would have for a later research project. Mm-hmm.
Okay, and the concept of having an image and text around it, where would you always have text around image that would provide context? So in a previous presentation, for example, we saw lots of newspapers being analyzed en masse. There are photographs or images or cartoons in newspapers with little captions under them, but the caption typically doesn't really explain what is happening on the picture. So in that context, would you need to sort of take into account the image and the surrounding article as a whole, or how much text around an image is sufficient?
So we particularly focus on use cases where indeed images are embedded in text. Mm-hmm. So we ignore indeed the use cases where there's only an image, because that would be the traditional computer vision-based image description problem, which we do not try to address. So the use case we have in mind is indeed something like ebooks or magazines where there's text and images combined. And the more text is surrounding an image, the better it is, because that provides more context to be accessed by text mining technologies. These captions, which are typically accommodating images in many media, they're of course extremely helpful. But we worked on collections where there were not even these figure captions available. So we would also provide those from the surrounding context and the image annotation, which is done automatically by deep learning applications. Mm-hmm.
On one of your slides, you had also a bullet that says translate into Dutch. So is it language dependent? Are you depending on some specific language technologies for this project?
So that's a very, very interesting question, because the problem is that nearly all current cutting-edge image recognition and image classification technology, but also text classification technology, is developed for English language. Also from a research perspective, this is a very strategically sound choice, because I, as a researcher, would of course want to reach an audience as big as possible and develop my technology for English language. And this is what a lot of people do. Now, the problem is, working together with Dutch libraries, the majority of their corpus is in Dutch. And many of the really cool toys don't work on Dutch language. So now we have this awkward workaround that you translate from Dutch to English and then translate back, because that works better than training our own technology. Because even something like BERT, I mean, one doesn't just train a new language model in your own language just easy peasy. Somebody else has to do that. Mm-hmm. And then with these image annotation frameworks, they're really big and expensive, and we as a smaller institution simply don't have the capacity to make a specialized version in our local language, which would be Dutch in this case.
Mm-hmm. Yeah, here in Estonia, we've also been hampered by, let's say, the slow development of language technologies. It's a small country, very few people speak this language, and technology tools are, let's say, expensive and complicated to develop. So the usage, or let's say use cases of AI are for the moment somewhat limited by what the text analysis tools can do for us. Okay, thank you, Christoph.